Hi, my name is Matt Nowinski, and I'm a member of the support staff for the Stone Edge Observatory. Today I'm going to walk you through an activity involving asteroid astrometry. You can find a hard copy of this tutorial at the link shown here. Before we begin the activity, I thought I would tell you a little bit about what asteroid astrometry is. It's a field of astronomy dedicated to locating asteroids in the sky in order to determine their orbits. For near-Earth asteroids, for example, this type of work is an important part of identifying and tracking those asteroids which might pose a risk of impacting the Earth. When a new near-Earth asteroid is discovered, astronomers around the world point their telescopes towards the new object and perform the astrometric measurements required to calculate its exact orbit. As you can imagine, astronomers use sophisticated software that is designed for this very task. In this tutorial, however, we are going to use Stone Edge Observatory's very own Astro Image Processor software, or AIP for short, to do some quote-unquote poor man's astrometry. Specifically, we are going to use AIP's RGB plot wizard function, normally used to create pretty color astrophotos, but instead we're going to use it to highlight an asteroid's path across the sky. Before we get started, you're going to need a few things. First, grab a copy of Astro Image Processor version 3.4.8 or later. If you don't have it, you can download it using the link shown here. AIP is a Java program, so you will also need to be sure that Java is installed on your computer. If it's not, you can get Java using the link shown here. Next, you will need a set of asteroid observations. These observations can be your own or downloaded from another source like Skynet. The only requirements are that the images are in the standard FITS format and that they were obtained with the telescope's sidereal tracking enabled. In other words, the telescope was tracking a fixed point, right ascension and declination, in the sky. If you don't have a set of asteroid observations to use, you can download a sample set from one of the URLs below. And I've included links to two asteroid observation sets, one for asteroid 24014 and one for asteroid 4434. Both of these observations were obtained using Stone Edge Observatory. If you use one of these sample sets, be sure to unzip the zip file contents on your local hard drive before proceeding. Okay, now that we have everything we need, let's get started. Launch Astro Image Processor by opening the AIP.jar file. Double check that you have the right version of AIP by looking at the version listed at the bottom left. You should have version 3.4.8 or later. Next, from the top menu, click RGB Plot, then RGB Plot Wizard. The program will ask you to open the red FITS file. Now note, AIP's RGB Plot Wizard function is normally used to build color astrophotos by stacking a set of filtered images. In this tutorial, though, we are going to use AIP to stack 3 images from our asteroid observations, taken at 3 different times, and highlight the location and movement of the asteroid across the sky using the colors red, green, and blue. So in this step, you're going to want to choose the first image in your asteroid observation sequence. I'm going to use the data set for asteroid 24014, and the first image in that observation sequence is indicated by an index 000. So I'm going to choose that file and then click Open. In the next step, the program asks you to open the green FITS file. In this step, choose an image that's taken near the midway point of your asteroid observation session. One easy way to find this is to count the number of total images and divide by 2. For this data set, if I scroll to the right, the last image in the sequence has an index of 084. Divide that by 2, and I get 42. So I'm going to choose the file with the index 042 for the green FITS file and then click Open. In the next step, the program asks you to open the blue FITS file. This should be the last image in your observation sequence. In this data set, that's 84. It has an index of 84. So I click that file, the last one, and then click Open. In the next step, the program asks to open a reference FITS file. This file is used as a baseline for adjusting the contrast of the stacked images. To make things easy, just choose the first image in your observation sequence, the same one you chose for the red FITS file. So in this case, it's the one that's marked with the index 000. Then I click Open. In the next 3 steps, you will align the 3 images that you chose for the red, green, and blue FITS files. In each step, 2 images will be overlaid, one tinted red and one tinted blue. To start, Astro Image Processor tries to align the red FITS file with itself. Since these are already aligned, I'll just click Save for this first set. For the second set of images to be aligned, what I like to do is in the window on the right, I click on a bright star, and then I get a zoomed in view of that star at the bottom left. And now you can see that you have the same star tinted blue and tinted red. And in order to align the two, we're going to use the buttons up, down, left, and right to align the blue and red versions of this star. So I'll click left here to move the red star over a bit. You have to be a little bit patient here because it takes some time to render the image, and then click down. And you want to just get it so that it's pretty close. It's hard to get the alignment exact. That looks pretty good, so I click Save. And now I'm in the third set of images for alignment. I do the same thing. I'll pick a bright star in the right window. I get a zoomed in view here in the left window. Click left. And then down. And then click Save, and the 3 images have been aligned. In the next step, we're going to move the red, green, and blue vertical slider bars to their maximum positions. Note, if we were producing a color astrophoto, we would normally adjust these values according to what we think the galaxy or nebula should look like. However, when using the RGB plot wizard for asteroid astrometry, instead we maximize the color intensities in order to emphasize the asteroid location and movement against the background sky. So I'm going to take each of these values, the red to the max, the green to the max, and the blue to the maximum value. Next, we're going to move the horizontal scale min-max slider bars to adjust the contrast of the image. And this is a little bit up to what you think looks best, but just as a hint, if you move the max slider bar to the left, you will make the bright objects in the image brighter. So you can see when I move it to the left, the stars get quite a bit brighter. By moving the min slider bar to the right, you can make the dark objects in the image darker. And that helps to remove some of the background noise. Okay, that looks pretty good. In the final image, the background stars will appear white, and the asteroid and its movement across the sky will be represented by 3 colored star-like objects. By the way, did you know that the word asteroid means star-like. The earliest appearance of the asteroid in the image will be colored red, the next green, and the latest blue. Take a moment and see if you can find the asteroid in the image on the right. It's right here in the center, so I'm going to click there and we'll get a zoomed in view. You can see the three appearances of the asteroid. Before we finish up, let's take a few moments to ask a couple of questions. In which direction is the asteroid moving? Are the three appearances of the asteroid spread evenly? What does this tell you about the asteroid's velocity? In this image, the size of the objects is related to its brightness. So the larger objects are brighter, the smaller objects are fainter. Are the sizes of the three asteroid appearances the same? Can you think of reasons that an asteroid's brightness might change with time? Let's take a couple of moments to think about these questions. Alright, now we're going to click Save, and we'll get a JPEG astrometry image. We'll save that. And that's it. Congratulations, you did it. Welcome to the wonderful world of asteroid astrometry.